All right, this is the second part of the oblique triangles test. I'm going to go ahead and do number 11 because it can be a little bit tricky. All right, this is side angle side. So we're going to use law of cosines. But we're going to use it twice because there could be a potential problem with side-side angle ambiguous cases. So the way we take care of that easily is here comes my law of cosines. A squared equals b squared plus c squared minus 2bc times cosine angle A. I go ahead and assign for opposite angle and side this piece for the angle and then this piece for A. So whatever this is going to be little a. A squared equals, these two don't matter, b and c, so 7 squared plus 9 squared minus 2 times 7 times 9, and then of course times cosine of 52 degrees. All right, that goes in the calculator. So let's put that in there. We've got, we can do this all at one time and just find the square root, or I can do it in two separate steps. I'm going to do it in two separate steps. 7 squared plus 9 squared minus 2 times 7 times 9, and then times cosine of 52 degrees, making sure that my mode is in degrees, and it is. And that's the first step, because remember this is the square, a squared equals. So I take the square root of that. Again, I could have done that in the first step, but I just chose to do it as a two-step. And that gives me 7.2. All right, so let's put that here. Now, to avoid confusion with ambiguous cases, I'm just going to go ahead and use law of cosines twice for side, side, side. All right, that's the easiest way that I've discovered to do that. So side, side, side. And my formula here is going to change ever so slightly. Again, law of cosines. And if I refer to this sheet, I'm pulling this formula from right here. Okay, looks kind of small on yours, but this is where I'm getting that formula from. So we're going to do cosine A is equal to b squared plus c squared minus a squared all over 2bc. All right, that's the one that I'm using right now. We're going to fill these in again with a different reference angle. Since the question does ask me to find this angle for theta, I'm going to let that now be the A. All right, and then this side will be my little a. So I'll just label these now that we're in the second part. Okay, so I'll make this my big A, this my little a, and these won't matter, so we'll just let this be B and this is C, not for any particular reason. So cosine of theta is equal to b squared 7.2 squared plus c is 9 squared minus 7 squared all over 2 times 7.2 times 9. Okay, we'll put that in the calculator. Again, I could do it as a one-step. I'm going to go ahead and do it as a two-step equation. All right, so let's do parentheses 7.2 squared plus 9 squared minus 7 squared divided by, and then of course 2 times 7.2 times 9. Okay. And that gives me the answer for this side. So I now take the inverse cosine, second cosine, pull that down, bam, there it is. And enter gives me 49.6, 49.7. Okay. Again, if you pull exact values, you may or may not come up with a rounded value for that one. So 49.6 or 7 is going to be an acceptable answer for that one. All right, let's do number 15, word problem. This has got bearing in it. So we'll create ourselves a compass. We've got 2 ships leaving a port. All right, traveling different rates of speed. A couple of things to remember here is that knots means nautical miles. Okay. And then we'll do some subtracting as we need to. So bearing, first one says ship Uno leaves on a bearing of north 72 degrees west. All right, that's going to be from north towards the west, 45, 60, 72. Okay, so 72, right about in here somewhere. And that's a vector. We'll let this be 72. Okay, and then that's ship Uno. And Uno is traveling at a rate of speed of, in this particular case, 80 knots. Okay, so since we're looking at a time unit here of 4 hours from 2 p.m. to 6 p.m., we're going to multiply that times 4. And that's going to give us 320 for our distance of nautical miles. So this is our 320. Okay. And then we're going to do the next bearing for ship Dos, and that's a bearing of 203 degrees. We started north. We traveled 203 degrees. I'll do a little subtraction over here. 203 minus 180. And that gives me 23 degrees in addition to 180. So about 23 degrees is right in here somewhere. And this will go a little bit further because it's going a little bit faster. So let's let this be our on a bearing of 203. And this will be our 23 right here. Okay, 23. And that's important when we come into this angle right here to find that angle measure. So 23 on a bearing of, ship Dos is traveling at 93 knots. Times, again, 4 hours from 2 p.m. to 6 p.m. And that's going to give us, I believe it was 372. I'll just double check real quickly. 12, 1, 30, 37, that's it, 372. So this distance is 372. All right, we create a triangle here. This is not necessarily drawn perfectly to scale, so that may or may not be perfectly straight up and down, and we don't want to use it that way. So this is what we're looking for. This is the angle that we're going to be using with the two sides. We know this is 72 and this is 23. So we do 72 and 23 is 95, and we subtract that from 180 degrees in order to figure out what this measure is right here. 72, 23, 180, and we get a total of, let's see, 95, 180 is 5, 17, 85 degrees. So this is our 85. We'll just throw that in there, right there. And then we're going to be looking for this side length. We'll call it A, because it'll work with our formula better that way. We'll call this angle A, big A, side length A, angle little a. This is side angle side. So we're looking at law of cosines. And we're going to use our A squared equals B squared plus C squared minus 2bc times cosine of A. All right, so we've seen this before. This is going to be what I don't know. This is going to be 3, it doesn't matter for these B or C, 320 plus 372 minus 2 times 320 times 372 times cosine of 85 degrees. And I'll try to be a little more accurate this time. Okay, so when we do this, we can throw in everything at once. We have to be careful when we do that. So second square root, and then 320 squared plus 372 squared minus 2 times 320 times 372 times cosine of 85 degrees. All right, scroll to the right, enter, and that gives us an answer immediately for A instead of having to do it in 2 steps. 469.1 is going to be our side length for that one. All right, we're going to do one more word problem in this video, the second part of of our oblique triangles. This is number 17. We'll talk about how to set it up. I'll probably let you do the very last part yourselves, but we're looking at a tower on a hill. Okay, so there's the hill. I'm going to go ahead and create the ground. And in just a second here, I'm going to create, as you'll see, an imaginary horizontal with the ground, with that slope, all right, perfectly at the base of that tower, okay? Then I'm going to create a guy wire that comes down and attaches to the ground. Okay, from the top of the tower, we're told the tower is 45 meters. And we're told that the guy wire is 62 meters. Okay, just a couple of things that are interesting here. Here's a 90-degree angle. All right, we're told that the slope of the hill is 9 degrees. So that occurs here, but it also occurs as well right here. Okay, that's also 9 degrees, which makes the total for this inside angle 99 degrees. Okay, so there's some really important information, all right? You've got two parallel lines cut by transversal, so these two alternate interior angles are congruent to each other. All right, we're now going to set up side-side angle, because that's the information that we have, side-side angle. There's two steps to this, because in order for us to find this distance from the base of the tower to where the guy wire attaches, which is what we're looking for, we'll call that X. We're going to have to come in here and find an angle measure here at the top to use with law of sines. So we'll need to know what that one is. We'll call that theta. And because it's side-side angle, right, I'm missing two of my angles, and so I'm going to have to find this angle down here as well to make that happen. We'll call that angle A, just for the heck of it, to make life a little bit nicer. So when we set up side-side angle with law of sines, and we could use law of cosines, but we'll stick with this at some point, but we'll go ahead and stick with this for right now. Law of sines, we're going to have to do pieces that we know. So we're going to do sine 99 over 62. And we're going to set that equal to, we got to use this A value. So sine of A over 45. Okay. That's going to give me the measure of angle A, right, which in turn is going to allow me to set up and solve for this third angle, 180 minus the two angles added together, right? And then I can set up my law of sines with this last ratio, an angle and its opposite side. Okay, so let's go ahead and get this one underway. This is my 62 sine A is equal to 45 sine 99. All right, I'm dividing by 62, and I'm doing the inverse function of the sine to make that work. So let's see what happens here with that one. We're going to do inverse sine, and we're going to type in 45 sine 99, and we're going to divide that by 62. Okay, that's going to give me 45.8-ish. So measure angle A, 45.8. All right, we'll just put that right here, 45.8. And remember that your last step is going to be, well, second to last step, you're going to add together your 45, your 99, subtract that from 180. All right, and in the interest of time, that's going to give us, just make sure we got the, well, you know what, let's just go ahead and do it. 180 minus 45.8 plus 99. Okay, we'll run the numbers on that real quickly. 180 minus 45.8 is this one, plus 99. And that gives us 35.2. Okay, so measure angle theta is 35.2. So let's put that right here, 35.2. And now we can set up our last ratio for law of cosines. I'll set it up for you and let you do it yourselves. So law of sines, We're going to do our standard ratio, which is the nicer values sine of 99 over 62, which is what we used right here. And we're going to set that equal to now our sine of 35.2. And we're going to put that over our x value since that's the piece that we're missing. Okay. From there, cross multiply, solve to finish the value. All right, it's more than 15 minutes already, so let's go ahead and just finish that one. That's going to give us x sine 99 equals 62 sine 35.2. We're going to divide by sine 99, so x equals 62 sine 35.2 divided by sine 99. And we'll toss that into the old calculator here and see what happens. So 62 sine 35.2, close it, divide that by sine of 99, and we're looking at 36.2. Okay, so x equals 36.2.